At this point, you've learned many different ways to factor. You've learned how to pull out the greatest common factor. You've learned how to factor special cases, such as the difference of squares or perfect square trinomials. You've learned how to factor with regular trinomials. And then you've learned how to factor by grouping as well. Now that you've learned those different factoring techniques, in this lesson, we're going to put it all together and factor using several different methods. So when you're factoring, some guidelines for factoring completely are as follows. First, make sure that you factor out the greatest common factor. That should always be the first thing you look for. Always look for a greatest common factor to pull out. From there, you want to look for your special cases. So look for your difference of squares and your perfect square trinomial. If it's neither of those, and it's a trinomial, then look for a pair of binomial factors, such as like x minus 2 times x plus 4, or something like that. If it's not a trinomial, let's say it has 4 or more terms, then you might want to try to factor by grouping. Once you have factored, make sure that whatever you have now at the end is prime as well, because sometimes once you factor, you can actually factor a second or a third time. And then finally, just check your answer to make sure that your solution is correct. And you can do that by multiplying back out. So here are a couple examples of where you need to factor completely using multiple methods in the same problem. Example 1, you have negative 3x to the fourth plus 30x to the third power minus 75x squared. So the first thing you always want to do is check to see if there is a greatest common factor. So notice that each term, they each have a 3 in common. So part of your greatest common factor would be a 3. And then they both, or all three, have x squared in common. So the greatest common factor would be 3x squared. And usually it's better to make this first term positive. So to do that, I can actually pull out a negative 3x squared. Because when I do that, I have negative 3x squared outside of parentheses. And then inside, I'd have a positive x squared for the first term, because I'd multiply to get negative 3x to the fourth. And then the second term would be negative 10x, and the third term would be a positive 25. And I get those terms because negative 3x squared times the x squared would give me negative 3x to the fourth. Negative 3x squared times negative 10x would give me a positive 30, and then x to the third power. And negative 3x squared times 25 would give me negative 75x squared. So we have pulled out the greatest common factor of negative 3x squared. Now from here, we have this trinomial in parentheses, x squared minus 10x plus 25. So from here, we can actually factor again. So we can factor again where we have x and then x to get the x squared for the first term. And then the 25, we have to figure out what multiplies together to get 25 and would add to get negative 10. Well, I would find that 5 times 5 would be 25. If I make them both negative, negative 5 times negative 5, those would multiply to get positive 25. And then negative 5 plus negative 5 would add to get the middle term of negative 10. So x squared minus 10x plus 25 can factor to be x minus 5 times x minus 5. So x minus 5 times x minus 5, we could write that as x minus 5 squared if we want. And that is as far as we can take this. So this down here, the negative 3x squared times x minus 5 squared, that would be your factored form. We have factored completely by pulling out both the greatest common factor, and then we have factored the trinomial that was remaining. Here's another example where you must use multiple methods to factor. So the first thing, as always, you want to check for the greatest common factor of all the terms. So looking at 10, 6, and -4, the greatest common factor of those numbers would be 2. And then looking at the x's, we have 3x's, 4x's, and 2x's. So they all have 2 in common. And looking at the y's, we have 2, 1, and 3. So they all have just 1 in common. So the greatest common factor would be 2x squared times y. So I pull that out, I'm left with something in parentheses. So 2x squared y times what gives me the first, middle, and then the last term. Well, 2 times 5 is 10. X squared times 1x would be x to the third, and then y times y would be y squared. The second term, 2 times 3 would be 6. X squared times x squared gives me x to the fourth, and then the y's are already okay. And then the third term, 2 times a 2 would give me 4. The x squareds are all right, and then the y's, we have 1, we need 3, so y times y squared would give me 3y's. So in parentheses, I would have 5xy plus 3x squared minus 2y to the third power. And we see that typed up right over here. So we have pulled out the greatest common factor. Now from here, we have this trinomial in parentheses, 5xy plus 3x squared minus 2y squared. In this case, it's going to be helpful if I put the 3x squared first in the parentheses, and then the 5xy, and then the minus 2y squared, because when it's in this format, you can see more quickly how to factor. So this could actually factor as a set of binomials. So 2 different set of parentheses. Now to get 3x squared, it would be 3x times x. That is the only way to get that first term of 3x squared. Now looking at the last term, negative 2y squared, the only way to get that would be with 2 times 1, I guess 2y times 1y, where either the 2y is positive and the 1y is negative, or the 2y is negative and the 1y is positive. So if I experiment by plug in 2y in with the 3x and then 2y in with the 1x, we would find that if we do 3x minus the 1y and x plus the 2y, that would give me back out these middle and last terms, because we have negative y times positive 2y, that would give me negative 2y squared, and then we have to check the middle term, so we have negative y times x, that's negative xy, and then 3x times 2y would give me a positive 6xy. When I add those together, I get 5xy. So this combination would give me the first, middle, and last term back out. So that will factor to be 3x minus y times x plus 2y. So that right there is the factored form of that trinomial above. And so this is as far as I can factor. So we have factored completely by pulling out the greatest common factor and then by factoring what was remaining. One more example. Here we have x squared times y times z minus 4 times y times z plus x squared y minus 4y. So the first thing you always want to do is check for a greatest common factor. So looking at all 4 of the terms, notice they all have a y in common. So I can factor a y out, then I'm left with 4 terms in parentheses. So the first term would be x squared and then z, because x squared times y times z gives me that first term of x squared times y times z. And then the second term, we need a 4 and a z multiplied with y in the front to get that middle term. The third term, we just need an x squared times the y. And the fourth term, we just need a negative 4 multiplied by y. So I have factored a y out, and I'm left with these four terms in parentheses. And we see that typed up right here. So that y would be the greatest common factor. Now from here, we want to work within the parentheses, and notice they have four terms. So this is not going to factor like your traditional like x minus 2 times x minus 7 or something like that. Because there are four terms, we want to consider factoring by grouping. So that is what we're going to do for this next step. We're going to begin factoring by grouping. So I've grouped together the first two terms and then grouped together the last two terms. And I group them together by putting them in parentheses. So from here, I look within each set of parentheses and see if I can pull out a greatest common factor from them. So the first set of parentheses, I see that they both have a z in common. So I pull a z out of the first parentheses, and I'm left with x squared minus 4. The second parentheses, nothing can be pulled out, so that would just remain as it is. And we can assume there to be a 1 in the front of this x squared minus 4. So we can write it with the 1 in the front. There's 1x squared minus 4. So when I factor by grouping, I see that they have an x squared minus 4 in common here and here. So I pull that out. That's what I see right there. And in parentheses, I'm left with the z plus 1. So factoring by grouping would give me x squared minus 4 times z plus 1. Now there's actually one more thing I can do. Notice the x squared minus 4 is a difference of squares. I have an x being squared minus 2 being squared. So that can factor, and that will be x minus 2 times x plus 2. So my finished product is going to be y times x minus 2 times x plus 2 times z plus 1. So we have factored this completely by doing the greatest common factor. We have factored by grouping, and we also did the difference of squares. And that concludes our lesson for today. We will see you next time.